In this video, I'm going to apply the parallelogram law of vectors to find the resultant of two vectors using this equation that I showed you how to derive this in the last video lesson. So given that two forces, 10 Newton and 14, they act at a common point O, for instance, and the angle between the two vectors, the two forces, is 70 degrees. We want to find the magnitude of the resultant vector as well as the direction. So I'll come back to this equation. Okay, but if I want to do a quick sketch, let's see this is how the two vectors are acting. This vector, let's see this is my 14 Newton force and this is my 10 Newton force. This angle, they are both acting at point O. This is angle 70 degrees, angle between two vectors. So from the equation I have r squared equals my vector p, I take that as 10 Newton, that's 10 squared. My vector p, I take that as 14 squared. Then plus 2 times 10 times 14 cos 70. So you have to get ready your calculator here so that you can follow me as I go through this step by step. So this is 100 squared 100 plus 14 squared is 196 plus 2 times 10, that's 20. 20 times 14, that is 280 cos 70. Now the rule of Boltzmann must apply here because you know that multiplication comes before addition or subtraction. So I'm going to say this is 100 plus 196. Then what I'll do is to multiply 280 by cos 70. Multiply 280 by cos 70 in degrees. That gives me 95.8 approximately. So I must do this first before I add this to this to this. So that gives me 296 because okay, this is equal to, so that gives me 391.8. Now this is my r squared. What I'm looking for is the resultant, that is the magnitude of the resultant vector, which is going to be the square root of 391.8. So that will give me 391.8 will give me 19.79, which is approximately or roughly zero point 0.8 Newton. So that gives the magnitude of the resultant vector using this equation, the parallelogram law of vectors, to calculate the magnitude of two given forces, 10 Newton and 14 Newton. So to calculate the direction of the resultant vector, I have to refer to this diagram. Let's say this is the picture of the two vectors, two forces, 10 and 14, acting at point O. Now this is the angle 70 degrees, which is the angle between the two vectors. This is the resultant line. Now the angle the resultant line makes with this, let's say this is the x-axis, is the direction of the resultant vector. And I'm going to find that using sine rule. I stated that in the last video on when I was trying to determine the equation, the formula for finding the magnitude and the direction of the resultant vector. So quickly I'm going to say sine alpha, looking for this over the side that is opposite the angle alpha. This is my angle. This side is opposite it over 10 equals, now since this is 70 and these two angles are on the straight line, so recall the straight line geometry that the sum of angles of a straight line equals 180. So this is 70, so this will be 180 minus 70. That will give me 110 degrees. So that gives me sine 110 degrees divided by, now this side is the side that is opposite the 110. That will give me over resultant, which I already found, 19.8. So that if I cross multiply, I have 19.8 sine alpha. If I cross multiply equals 10 sine 110. So that my sine alpha now equals 10 sine 110 divided by 19.8. So I'm going to evaluate that directly. So that I can have my answer. That is giving me 9, 9.3969 divided by 19.8. That is 10 multiplied by this gives me that. So that my sine alpha now will be equal to that divided by 19.8. 19.8 gives me 0.4745. So that when I find the inverse, the sine inverse of this figure, 4745, if the sine of an angle alpha equals 4745, the question is what is the value of angle theta? So then I take the sine inverse. In most calculators, it's the shift function you're going to use. Shift sine will give you of this will give you alpha as 28 to the nearest 0 0.1 degree to the nearest 0.1 degree. That gives you 28.3 degrees. So this is how we apply the cosine formula and then the sine formula also to calculate both the resultant, that is the magnitude, and the direction of the resultant vector respectively. Now suppose angle theta is obtuse. Okay, theta is not acute now. Obtuse, that's an angle greater than 90 degrees. How do you use the same equation? Keeping P constant. Let's say the vector P still remains 10 Newton and vector Q is still 14 Newton. This time around, let's say angle theta is now 140 degrees. How do we determine the magnitude and the direction of the resultant? In this case, the same formula, r squared equals 10 squared plus 14 squared plus 2 times 10 times 14 cos 140. Now 140 is an angle in the second quadrant because it's an angle greater than 180, greater than 90 degrees rather. So that gives me 100 plus 196 plus this is 280 cos 140. Now when I get back to my calculator to find cos 140, it will be negative. Yes, to give me a negative value because 140 is in the second quadrant. So cos 140 multiplied by 280 will still give me a negative result, minus 214. That gives me minus 214. So I have here 100 plus 196 plus this gives me minus 214.5. That's the nearest one decimal place. You see that now? That's evaluate this first, following the rule of BODMAS. This times this gives you negative. So you have to take note of that. That gives me this plus this 296 multiplied negative by positive or positive by negative. That gives you minus 214.5. That is equal to my R squared. So my the difference will give me 81.5. That is my R squared. So I'll quickly take the square root of 81.5. That will give you 9.0. So that finally my vector R is equal to, taking square root of this will give me 9 point, roughly 9.0 meter. So that is it. When the angle between the two vectors is obtuse, an angle greater than 90 degrees. So we follow the same approach to find the direction using the same equation to determine that. Now, before I round off this session, I want to stress out one or two facts you need to be aware of. That is, when it comes to an application, applying this equation to solve questions, finding the resultant of two vectors. Let's look at this equation carefully. Now, this equation can be used for all angles of theta between 0 and 360 degrees. Yes, this equation can be used, when the angle of theta is between 0 and 360. Now, what happens? Number one, let's keep P and Q constant. Suppose our angle theta degrees is 0 degree. Okay, so what's the resultant vector? Let's rewrite it. R squared gives me P squared plus Q squared plus 2PQ cos 0. Recall that cos 0 is 1. So that gives me P squared plus Q squared plus 2PQ. Cos 0 is 1. 1 times 2PQ is 2PQ. That gives me R squared. Now, if you look at it by careful investigation and inspection, it's called that p squared plus q squared plus 2pq is same thing as p plus q all squared. Because when you expand p squared plus q squared plus 2pq, it gives you this. So if you take square root of both sides, your resultant r is p plus q, which we said earlier that when the angle between the two vectors is zero, meaning that the two vectors are acting in the same direction and they're both parallel to each other. So when the two vectors are parallel, acting in the same direction, the resultant vector, let's say call this p, let's call this q, the resultant is just the algebraic sum of the magnitude of the two vectors p and q. So you can see that this equation also applies when the angle between them in this case is 0 degree. What happens if the angle between two vectors is 90 degrees? Suppose the angle between them is 90 degrees. So we have r squared equals p squared plus q squared plus 2pq cos 90 degrees. Now recall that cos 90 degree, if you check from your four-figure table, is 0. That gives you r squared equals p squared plus q squared. You see that now? Because 0 times all this gives you 0. So that your resultant vector r is the square root of p squared plus q squared. That is to say the two vectors are acting perpendicular to each other when the angle between them is 90 degrees. So using the same equation, you can arrive at expression, the formula for calculating the resultant of these two vectors. Now what happens if theta is 180 degrees? When theta is 180 degrees, my r squared gives me p squared plus q squared plus 2pq cos 180. Now from the four-figure table, cos 180 in degrees is minus 1. So that gives me the resultant squared equals p squared plus q squared plus 2pq multiplied by minus 1. Now this negative 1 will multiply this positive sign to give you p squared plus q squared minus 2pq. That gives me r squared. So you can now see that by inspection, this sum, that is the term on the right hand side, simplifies to p minus q all squared. Because when you expand this, then you get back this. So that the vector r taking square root of both sides is p minus q. So when the two vectors act at angle 180 degrees to each other, that is the two vectors are anti-parallel. Let's say this vector p acting to the right and vector q acting leftward. The two vectors are anti-parallel. It means that the resultant is the difference, positive difference of the two vectors p and q. So you can see that this equation is, can I say, is universal in a way, because irrespective of the angle between two vectors, the equation can be used to determine the resultant of the two vectors. Finally, suppose you have the two vectors p and q, and then such that vector p is equal to vector q in magnitude. Vector p, let's say 5 Newton or thereabout, vector q is also 5 Newton. And let's also say that the angle between them is 60 degrees. What will be their resultant? Sometimes the angle can be 90 degrees. But suppose you are doing a case where the two vectors are equal. So when vector p equals q, so I can replace q with p, because this is supposed to be p squared plus q squared. But since both are equal, I'll replace that with that. That gives you 2pq, 2p times p, because I'm replacing vector q with p, because let's say 60 degrees, the angle between two vectors. So that gives me r squared equals p squared plus q squared. That gives me 2p squared plus 2p squared again cos 60, because this is 2p times p, 2p squared. So that gives me 2p squared plus 2p squared times 0.5, because cos 60 is 0.5. So 2 times 0.5 gives me 1 times p squared gives me p squared. That gives me 2p squared plus p squared, which gives me 3p squared. So that the resultant in this case, r squared, is 3p squared, and therefore r, if we take square root of both sides, is with 3 multiplied by vector p. So this is what happens when the two vectors, the two forces p and q are equal, and that the angle between them is 60 degrees.